Have you ever really stopped to think about what's going on inside a simple refrigerator or a walk-in cooler? I mean, we just trust them to keep our food cold, right? But underneath that simple exterior, there's this incredibly smart system constantly working, making decisions to keep itself safe and running just right. We totally take it for granted, but it's a real marvel of engineering. So that brings us to a kind of dramatic question, but it's a real one. How does this machine, which is juggling high pressures and pretty powerful electrical currents, keep from literally tearing itself apart? Well, the answer reveals this sort of hidden intelligence, almost like a brain that keeps the whole thing in check. And to get our heads around that brain, we're going to break it down. We'll look at three distinct layers of intelligence. First, the guardian, which is all about safety. Then, the lifeblood, which covers operation. And finally, the mission, which is capacity. And then we'll see how they all add up to a real formula for reliability. Okay, so the whole key to understanding how these things are so bulletproof is to stop thinking of the control system as one big thing. Instead, you've got to see it as three separate but totally interconnected layers of intelligence. And here they are: safety, operation, and capacity control. The best way to think about it is to compare it to a human body, right? Safety controls, those are your body's reflexes. Like when you touch a hot stove, you don't think, you just pull away. Operation controls are like your circulatory system, keeping the lifeblood pumping smoothly. And capacity control, well, that's the conscious mission, the actual job you're trying to get done. So let's start with the most basic, most important layer, the guardian. This is the system's deep down instinct for self-preservation, and its rules are absolute, no negotiating. The whole point of safety control is just one thing: prevent a total disaster. It couldn't care less about being cold. Its only job is to protect the expensive equipment from blowing up, and, of course, to keep people safe. It is the ultimate guardian, and it is always on watch. So, how does it pull this off? With these critical parts right here. You've got motor contactors, which are basically super heavy-duty electrical switches, and pressure switches that, you guessed it, sense pressure. Think of them as the system's big red emergency stop button. If pressure spikes or the electrical load goes haywire, these things don't think, they don't ask questions, they just act. They slam the brakes on and cut the power. Instantly. Now, what's really fascinating is where these guardians are located. See how they're all huddled right around the compressor? That is absolutely not an accident. The compressor is the heart of the whole machine. It's the most crucial and the most expensive part, so these safety controls are put there specifically to protect it, no matter what. Okay, so the system is now protected from disaster. We can move on to the next layer, operation. Now, if safety is all about preventing harm, operation is all about maintaining good health. This is the system's circulatory system. Its main job is to make sure the system just runs smoothly, day in and day out. And it does this by managing the refrigerant, which is, for all intents and purposes, the system's lifeblood. For anything to work, that refrigerant has to be clean, and it has to be flowing just right. And to keep that lifeblood in good shape, the system uses parts that are kind of like its own internal organs. The oil separator makes sure lubricating oil gets back to the compressor where it belongs, while the filter dryer is constantly cleaning out gunk and pulling out any destructive moisture. It is all about keeping that refrigerant pure. But it's not just about being clean, it's also about flow. So you have devices like the thermostatic expansion valve, we usually just call it a TXV, and other pressure regulators. These act like the really precise valves in our own circulatory system. They control the flow and create these very specific pressure drops that are needed for the magic of thermodynamics to actually happen and, create cold. And here's the difference. Unlike the safety controls that were all bunched up, these operational parts are spread out all over the place, all through the piping network. They're basically woven into the system's vascular system to treat and condition the refrigerant at every single step of its journey. All right, on to our final layer. So far, we've got a system that's safe, and we've got a system that's healthy. Now it's time to give it a mission, to actually make stuff cold. This is the capacity layer, the part that senses what's going on in the real world and responds to it. The job of capacity control is the one we all get, right? Its whole reason for being is to get to the right temperature inside the box and then keep it there. This is the part of the system that's actually doing what we asked it to do. And the logic behind it is just beautifully simple. The thermostat is your sensor. It's just sitting there, constantly measuring the temperature. And it follows a simple rule. If it gets too warm,
Then it zaps an electrical signal to a solenoid valve, which is just a fancy automated tap, and tells it to open up. That lets the refrigerant flow and starts the cooling. Once it's cold enough, it signals it to close. That's it. So simple, so elegant, and it just works.
So where are these parts? Well, their location is absolutely crucial. The capacity controls, your thermostat, your solenoid valve, they create this critical communication bridge. They are the link between the space we want to cool and the machinery that's actually making the cold happen. Okay, so we've got our three layers: the Guardian, the circulatory system, and the mission control. Now, let's put it all together and see how these separate ideas create one single, incredibly reliable system. And this map just shows it all perfectly. You can see the safety parts in yellow, all clustered around that compressor. You see the operation components in orange, spread all through the pipes. And you see the capacity controls in blue, linking the cold box to the whole system. They're not three different systems. They are one beautiful, integrated whole. This chart here is a fantastic summary. It just neatly puts every part we've talked about into its own box. But notice anything interesting? The thermostat and the solenoid valve actually show up in two columns: operation and capacity. And that just shows how some of these brilliant little components can wear multiple hats, helping to both keep the system healthy and carry out its main mission. And that brings us right to the end, to the big takeaway. This is it. This is the formula for reliability. You need the absolute non-negotiable reflexes of safety, plus the steady health management of operation, plus the smart responsive intelligence of capacity. You put those three together and what you get is a complete, tough, and truly reliable refrigeration control system. So, yeah, the next time you grab something from the fridge, maybe you'll just take a second to think about that elegant system humming away inside. It really proves that true intelligence isn't always some single super complex brain. A lot of the time, it's just a system of simple, reliable parts where each one has a very clear job and they're all working together in perfect concert.